Okay, part 2.2 part B is still dealing with trigonometric ratios of any angle. So we're just going to go a little bit further than we did in the last section in finding the values of angles. We need to remember, though, when we're doing this, what is our characteristics of the 45, 45, 90 and the 30, 60, 90 triangles. So if you want to just hit pause and try doing this on your own and see if you remember what they are, or you can just follow along with me, doesn't really matter. So 45, 45, 90. You have your triangle, looks a little better than that, with your right angle. So your ratios are the sides or the legs are 1 and 1, and your hypotenuse is square root 2. For the 30, 60, 90 triangle, this isn't that close, but we'll call this our 30 and this is our 60. The side opposite the hypotenuse has to have the longest measurement, so that is, our unit is 2 for that one. The side opposite the 30 is going to be, because it's half of the 60 degree, so it's going to have a measurement of 1, because if this had extended to make an equilateral triangle, then this would have to be half of 30, or this angle here would be half of 60, so it would be 30, so that means our side length would be half of 2, which is 1. And then the 60 degree gets the square root 3. The cast rule is just a way of telling where trig ratios are positive and where they are negative. So the cast rule starts in quadrant 4 and works its way counterclockwise around the coordinate plane. So C means that only cos is positive in quadrant 4. A means that they're all positive in quadrant 1. S means that sine is positive in quadrant 2. And T means that only tangent is positive in quadrant 3. Okay, so you're going to have to solve triangles. So for any given triangle, depending on, or angle, depending on what they give you, you're going to have to solve for that value. So either you're going to have to find out what the angle measurement is, or you're going to have to find out what the ratio of the sides would be. So step 1 says use the sign, positive or negative, to determine the quadrant the solution is in. So this one here, for A, my sign ratio is negative. So then I have to think, okay, using the cast rule, where is sine negative? So sine is negative. I'll just pull this down so you can see. So sine is negative in quadrant 3 and quadrant 4, because in 1 and 2, it's positive. So I know I'm looking at an angle. In quadrant 3 or 4. So that's where the terminal arm must be. So step number 2 is solve for the reference angle. So what you want to do, I'm just going to pause and, okay. So I know I'm looking at an angle in quadrant 3 and 4 here. So you draw that in. So this would mean my terminal arm, and I'll just use, is either going to be here, or it's going to be here. So that would mean my angle is either going all the way around to there, or if it's the purple guy, it's going all the way around to there. So if I finish off my triangles, I need to find then my reference angle. So if I take a look at this, I've got my ratios are 1 and square root 2. So 1 and square root 2 means that I have to use therefore I'm using the 45, 45, 90 triangle. So that's 45 degrees and 90 degrees. So that means that my reference angle then, that shouldn't be a Q, it should be a theta. My reference angle is equal to 45 degrees. So this and this are both going to be 45 degrees. Sine is opposite over hypotenuse, so you can check that. Opposite would be 1, hypotenuse would be square root 2, so that works for both of these because they are negative. And that would mean that my negative ones would be the negative values. So then to figure out what my reference angle is, I have to use my little kind of tips from the last section to figure that out. So in quadrant 3, to find my reference angle, or to find my angle in quadrant 3, it's going to be 180 degrees plus my 45, so that'll be 225 degrees. In quadrant 4, I have to go from 360 and back 45. So 360 minus 45, so that means this equals 315 degrees. So if I check, or if my solution is theta is equal to 225 and 315, put your box around there so I know that's your solution. You can check by putting this into your calculator. So if you check it on a calculator, sine of 225 degrees, if you round to 4 decimal places, will be negative 0.7071. Whoops. And if you try sine of 315 degrees, it equals negative 0.7071. Okay, so the biggest thing, or the thing to look at, is where is your solution going to be? Which quadrant based on the cast rule? Then you'll take a look at the values they've given you. So if it's a 1 and a square root 2, then you know it's going to be a 45, 45, 90. If it had a 1, 2, or a square root 3 in it, then you know it's going to be a 30, 60, 90. So let's try the next one. Cos theta is equal to 0.5, and my angles have to be between 0 and 180. So I've got a restriction on there. So my cos ratio, first thing I look at, cos is positive. Therefore, I'm looking at quadrant. Cos is, just so I don't have to move up every time, cos is positive in quadrant 1 and 4. So I know that's where my terminal arm is going to be. But my restriction here said, this restriction said it had to be less than 180 degrees. That means I can't use quadrant 4 because that would make it more than 180 degrees. So I'm only going to have one answer for this. So cos of theta is equal to 1 over 2, 1/2. So when it gives it to you in a fraction, or in a decimal, see if you can put it into a fraction that works. So 1/2, that means 1 and 2, that's 30, 60, 90. So that would mean, since my angle, then you draw it. My angle has to be in quadrant 1. Based on the information, cos is adjacent over hypotenuse, so this is 1 over 2. So then I take a look at my 30, 60, 90 triangle. The angle that, so if it's 1, 2, then that means this side here is square root 3. So which one has square root 3 as its opposite or has 1 as its adjacent? Go back up to the triangle here. Square root 3 is the opposite or 1 is the adjacent is the 60 degree. So theta is equal to 60 degrees. And you can check that on the calculator. So that's your solution. Okay, C, sine of theta is equal to negative square root 3 over 2. And I have to be between 0 and 360 degrees. So sine is negative. Sine is negative in quadrant 3 and 4. I'm using square root 3 and 2. So that means I've got a 30, 60, 90 triangle. I draw it. So quadrant 3 puts it here. Quadrant 4 puts it there. And remember, you're always drawing your triangle so that your right angle is being made with the x-axis, okay? Or your terminal arm is going from the origin and into the y's, either positive or negative y. So, which triangle has sine? So this is what I'm looking for. Sine is opposite over hypotenuse, so this is square root 3 over 2. I know that this is my negative. So using your 30, 60, 90, which one has square root 3 on the opposite side? Well, that's your 60 degrees. So I know my reference angle is equal to 60 degrees. So that means now I need to solve it. So that means theta in quadrant 3 will be 180 plus 60, so that's 240 degrees. Or theta could be in quadrant 4, which would be 360 degrees minus your 60, so it's 300 degrees. So that means theta is equal to 240 degrees or 360 degrees, 300 degrees. Fits within my restrictions. If I check, sine of 240 is equal to negative 0.866, and sine of 300 is equal to negative 0.866. So always just throw in that check just to make sure you've used the right angle. In case you might have mixed it up and went, oh, that's a 30 degree. If you put it in, 210, sine of 210 isn't going to give you the same answer as you got. Okay, the next one says determine the measure of theta to the nearest degree given. So sine of theta is equal to negative 0.8090, and theta has to be between 0 and 360. So you start with the same thing, even though they've given you this in, excuse me, in the negative 0.8, it's given it to you in decimal instead of giving you what does theta equal, or it hasn't given you your special triangle ones. You can still solve this. So we know that this is a sine ratio. Sine is negative. So that means sine is negative in quadrant 3 or 4. So to find out what our reference angle is, you write this as sine of reference angle is equal to just equal to a positive 0.8090. So on your calculator, then you would do sine inverse 0.8090. So that's sine second function. You find out that your reference angle is equal to, rounded, is 54 degrees, because we're rounding to the nearest degree. So if my reference angle is 54 degrees, that means I've gone 54 degrees this way. So in quadrant 3, theta is going to equal 180 plus 54, which is 234 degrees. In quadrant 4, which will be here, there's your reference angle. So that means that theta is equal to 360 minus 54. So that's 306 degrees. So again, you can check these on your calculator and you find out that they both equal negative 8.090. So theta is equal to 234 or 306 degrees. And that fits within our restrictions of 0 and 360. Tangent. So if, again, you look at this and you figure out, okay, what quadrants could we be talking about? So tangent is negative. So therefore, we're looking at tangent being negative in quadrant 2 or 4. So then we find what's our reference angle by doing tangent inverse of 0.7565. Remember, your reference angle is always positive. So your reference angle is equal to nearest degree is 37. So if I were to draw that in quadrant 2, reference angle would be about right there. In quadrant 4, my reference angle is, well, that's got a little bit wide, but you get the idea. So in quadrant 2 then, theta will equal 180 minus 37, because I'm going just a little off of that 180, so I have to take it away. So that equals 143 degrees. In quadrant 4, theta is going to be 360 minus my 37, so that equals 323 degrees. That falls between my restrictions, and you can check it on the calculator. Tangent of 143 and tangent of 323. And you'll find when you do that, your decimal is going to be off just a little bit, and that's just because we rounded. We rounded that to 37 degrees. If we had left it as a decimal, then we would have a more accurate answer. So our solution, theta is equal to that should be 143, or 323 degrees. Okay, so the biggest thing when you're doing these is you first figure out which quadrant you're talking about. Then you figure out if it's giving you exact values of 1, square root 2, square root 3, or 2. Which triangle are you talking about? And then draw it in there. Once you calculate the reference angle, draw those reference angles in their proper quadrants, and then figure out if you're adding 180 or taking away 180, or if you're taking the reference angle from 180 or adding it to 180, or if you're doing it from 360 degrees, subtracting from 360. So your questions are there. Good luck.